Ever wonder why skyscrapers won't fall? This video explains why. Welcome back to Explaining Difficult Stuff. The construction of today's skyscrapers is a complicated process. In just 5 minutes, we'll go over the stages of building a skyscraper from the ground up. A lot goes into creating a structure as complex as a skyscraper. Many components go into the making of these spectacular buildings, from excavation and steel reinforcements to concrete support beams. We won't go deeply into these topics, but we cover the basics so you can understand what's involved. Some technical liberties were taken to achieve clarity and simplicity. However, a solid working knowledge of how skyscrapers are built is presented. Please hit the like button and subscribe. It goes a long way. Our team of nerds and I hope you enjoy watching this video as much as we did creating it. Now on to skyscrapers. We hope you're not afraid of heights. Broadly speaking, there are 3 stages involved in building a skyscraper. We will explain the basics of site selection, design, and construction. So, let's begin with site selection. You know what they say in real estate, the 3 most important things are location, location, and location. It is certainly the case when considering where to build a skyscraper. Because of water tables, earthquake history, and average wind velocity, geography is crucial in how high you can go. Another issue to be considered when selecting a site is the average wind force in the area. To combat this, design features are built into the building to reduce the force of the wind and not sway so much that the occupants need to take something for motion sickness. Aerodynamically designed buildings help in this regard. Now that a site has been selected, the design process can begin. A major design issue are the elevators. Think about it, if elevators were never invented, there would be no skyscrapers. They significantly impact design and require precious space. They must be easily accessible, comfortable, and safe in tall buildings. Now we come to one of the primary points of interest of this video. A team of highly trained professionals skilled in different areas is in place. A site has been selected, and designs have been approved. A skeleton of the entire skyscraper must be erected. The heights attained today could not be reached without the use of these so-called skeletons. Now it's time to start excavating for the foundation, pouring concrete, and erecting the steel framing. Now the $64,000 question. How deep do you have to dig to prepare a foundation for a skyscraper? So, if you want to go high, you have got to go low. You must dig deep enough to find bedrock to anchor the weight of the building. When bedrock is far below the surface, vertical beams called piles are required to reach it. They are driven down until they come in contact with bedrock. Once the structure is attached, it can deal with whatever Mother Nature has in mind. This is the most critical step when laying the foundation. This will give the structure a center of gravity that is below the surface. Once done, it will never topple. Some of the tallest towers in the world had to go down almost 300 feet. It would be logical to assume that taller structures require deeper foundations. Although logical, it would be incorrect. Compare how far down the foundations of the tallest buildings in the world had to be dug. Notice that the tallest towers don't necessarily need the lowest foundations. From location to location, what's below the ground dictates what happens above it. At the risk of oversimplifying it, a skyscraper is a vast, 3-dimensional steel rectangle comprised of many smaller rectangles. This skeleton must safely handle strong winds, the weight of snow, floods, and earthquakes while remaining intact and safe for occupants. The skeleton is created using girders as the primary horizontal support for smaller beams. These girders are often referred to as I-beams. On every floor, vertical beams connect to the girders to form the internal rectangles and further strengthen the structure. This comprises the superstructure of the building. Everything that comes after that, like windows and other exterior objects, is just dressing. This approach weighs much less and therefore can achieve greater heights. As taller and taller skyscrapers continue to emerge, designers and architects will be challenged to develop new materials and systems to accommodate these massive structures. We said we would be done in a few minutes and we did it. You know more now than you did a few minutes ago. Hopefully, you were entertained in the process. If you hit the like button and subscribe to life-changing innovations, it would be greatly appreciated. We post a new video weekly. When you subscribe, you'll automatically be notified when they are available. In order to keep things clear and simple, we take liberties with some technical concepts. But fear not, a good understanding of the topic is presented. Until next time, thank you for watching. Remember, there's no cure for curiosity.